Units 9 through 10, Exponents and Logs, Booklet 2. Formulate exponential equations. When formulating from these word problems, use these formulas to help solve the equation. Here are some terms that may show up in these problems and what they mean. Annually means 1 time per year. Semi-annually is twice a year. Seasonally is 4 times a year. Monthly would be 12 times a year. Weekly, 52 times a year. And then daily, 365 times a year. Let's look at the first problem on here. Joe invests $7,024 in a savings account with a fixed annual interest rate of 2% compounded monthly. What will the account balance be after 4 years? You want to list out each of the variables on these problems. We want to find P, the principal amount, R, the interest rate, T, the time in years, N, the number of times it's compounded, and then A, the current account balance. It says that Joe invested the $7,024, so that is P. R, you want to have that standard form. 2% is 0.02. 4 years, so T is 4. And then it says monthly, so we're going to put 12 for N. And then A, we don't know what that is yet. So we want to evaluate for A. We're going to use this first equation right here. So we'll go ahead and write that down on our problem. A equals P parentheses 1 plus R over N to the NT power. And then we'll plug in the numbers. A equals 7,024 times 1 plus 0.02 over 12 to the 12 times 4 power. From there, you could put it into the calculator to approximate it with 2 decimal places. So we can go to Desmos and then type this in. And so your answer is $7,608.50. Let's look at the next one. Jill invests a sum of money in a retirement account with a fixed annual interest rate of 5% compounded seasonally. After 16 years, the balance reaches $24,204.84. What was the amount of the initial investment? So let's write out all of our givens. P is for the initial investment. We don't know what that is, so we'll leave that blank for now. R is the interest rate in standard form. 5% is 0.05. T was 16 years. N was seasonally, so that's 4 times a year. And then the account balance was $24,204.84. So this one, let's go ahead and write out the same formula as before. Except for this time, we're going to divide everything by everything on the right side of the equation except for P. Okay, we'll plug in all of our values and then approximate it. 24,204.84 divided by 1 plus 0.05 over 4 to the 4 times 16 power. And we'll type this into Desmos around 2 decimal places. So our answer, our principal amount, is $10,930.00. Alright, the next one. Jessica invests $1,994 in a savings account with a fixed annual interest rate compounded weekly. After a decade, the balance reaches $4,007.26. What is the interest rate of the account? Let's write out all of our givens. She originally invested this amount of money, so that would be the initial amount. $1,994. The interest rate, we don't know what that is yet. The time was a decade. 1 decade is 10 years. And then the new balance was $4,007.26. It was compounded weekly, so N is going to be 52. So we look at our formulas up here. We want to use the one where R is solved for. We have times 100 because we're changing it to a percentage. Okay, write out the formula and then plug in each of the givens. $100 times 52, parentheses, 4,007.26, divide by 1,994, close parentheses, raised to the 1 over 52 times 10 power minus 1. And then we'll type that into the calculator. So it looks like we have about 7% here. Jimmy invests $3,385 into a savings account with a fixed annual interest rate of 3% compounded semi-annually. How long would it take for the account balance to reach $5,000? So we'll write our givens. 3% is 0.03. The time, we don't know what that is yet. Semi-annually is twice a year. And then it was to reach $5,000. So we want to use the formula with T solved for, so let's write that one on our problem. So then we have T equals ln of 5,000 over 3,385 divided by 2 times ln of 1 plus 0.03 over 2. Then we'll type this into the calculator. Then we get about 13 years. There exists 4,196 bacteria on a surface of something. If the population grows each minute at a rate of 20% compounded continuously, how long would it take for the population to reach over 100,000? Round to the nearest whole number. So let's write our givens. We have the original amount. We have the growth rate, which is 0.20. T, we don't know what that is. And then the new population would be 100,000. Notice it is compounded continuously, so n would be approaching infinity. When that is the case, we'll not have n in the formula. We'll use this one with E, Euler's number, instead. And then we'll plug in our givens. 100,000 equals 4,196 times E to the 0.2 times T. To solve, we're going to divide each side by 4,196. And then rewrite it. 100,000 divided by 4,196 equals E to the 0.2 T. To get rid of an E, we're going to ln each side. That gets rid of these. And then we'll rewrite it again. ln of 100,000 over 4,196 equals 0.2 T. To get the T by itself, divide each side by 0.2. And then we have T equals ln of 100,000 over 4,196, all divided by 0.2. Let's type this into Desmos. ln of 100,000 divided by 4,196, all divided by 0.2. We get about 16. And it's not years this time, it's going to be minutes. For these types of questions, normally they will only give you this formula with the A by itself for non-continuous compounding, and then the one where A is by itself for the continuous compounding. You'll need to either remember or know how to formulate and derive these other formulas. Formulate an exponential equation for the data using regression. For these types of problems, you're given a table and you want to put this into Desmos. You go to desmos.com/calculator, insert table, and then to get exponential regression, you'll type in the formula y1 tilde a parentheses b to the x1 power. So on Desmos, you press the plus sign, click Table, insert your values from the given problem, and then type the formula. Y1 tilde A B to the x1 power. And that gives you your A and your B, and you'll use that to find your equation for Y. So we have A is a 2.36268, and then B is 2.51386. And then for our equation, we could just round these. So we have y equals 2.36 times 2.51 to the x power. And that would be your formula. A car that is originally valued at $28,000 depreciates in value by 20% each year. Write an exponential function to model this. So for this one, it says originally valued. That is going to be A1. Initial value right here. Depreciates will make the R negative, and then R would equal 0.20. So we'll write those here. So A1 is 28,000. R is minus 0.20. And then so the formula, you would write 28,000 times 1 minus 0.2 to the x power. If you evaluate this, you get 0.8. Our formula would be 28,000 times 0.8 to the x power. A painting originally valued at $100 appreciates in value by 15% each year. Write an exponential function to model this. A1 is the initial value, that's $100. R is going to be positive since it appreciates, so it's going to be plus 0.15. Plug that into the formula. 100 times 1 plus 0.15 to the x power. That will give you 1.15. So it increases by 15%. So the whole thing will be 115% of the original value. Our formula is f of x equals 100 times 1.15 to the x power. Suppose Molly had a starting annual salary of $52,000. She gets about a 3% raise each year and works for 45 years. How much earned income will Molly earn? A is the initial amount, that is $52,000. R is going to be the raise plus 100%. This could be 1.03. And then N is the number of years, 45. To get the total earned income, S of N, we plug it into this formula. And then from there, you'll use a calculator. Just type that in. And then we get this output. And then we'll round 2 decimal places to get $4,821,432.79. So this one was a finite geometric series. Let's look at this one. Find the sum of the finite geometric series. It's the same thing without a specific application. We have the summation from k equals 1 to 7 of 2 times 3 to the k minus 1 power. Let's identify A, R, and N. A is the initial value, that's 2. R is the common multiplier, the common ratio, it's 3, and then N is 7. We'll plug it into this formula, and then you get 2 parentheses 1 minus 3 to the 7th power all over 1 minus 3. We'll plug this one into the calculator just like the previous example. So S of 7 is equal to 2,186. The next one is an infinite geometric series. We have the summation from k equals 1 to infinity of 4 times 1/2 to the k minus 1 power. Our formula is A over 1 minus R, and the R has to be less than 1. R is less than 1 here, it's 1/2. If it wasn't less than 1, it would diverge and you wouldn't be able to find a specific number answer. So let's plug it into the formula. 4 over 1 minus 1/2. It's 4 over 1/2 equals 8. So the summation is 8. For a certain drug to have the desired healing effect and be safe, the amount in a person's system should be between 60 and 70 micrograms. After 6 hours, the amount of a dosage of the drug left in the body is 70% of the original dosage. Each dosage of the drug delivers 20 micrograms to the body. Assume a person receives 1 dosage of the drug every 6 hours. When, if ever, would the amount of the drug in a person's system be greater than 60 micrograms? We write this out for each dosage. Let's see if we can find a pattern. We have 20 micrograms. Okay, 6 hours later. Would be the second dosage. We have 20 micrograms and then plus the existing, which would be 70% what was already in there. And that would be 34 micrograms. And then the third time, we're going to have 20 micrograms plus 70% of what's left of the body, the 34. And that's going to equal 43.8 micrograms. And then we have the 4th dose. You add another 20 micrograms plus the 70% of the 43.8 micrograms. 50.66 micrograms. And the 5th dose, 20 plus 70% of the 50.66 micrograms. And then we'll add 6th dose, 20 plus 70% of the 55.462 micrograms. And then, so that gives us 58.8234. And then the 7th dose, we have the 20 plus 70% of that 58 number. And then that will give us 61.2. So after the 7th dose, that's when it's greater than 60 micrograms. Now instead of writing this all out like this, you could also use the finite geometric series formula. We would identify A, R, and N. A is the dosage, which is 20 micrograms. The rate is going to be 70%. And then N, we wouldn't know what that is. And the S of N has to be greater than or equal to 60. First, we'll write the formula. We'll plug in our values and solve for the unknown. So 60 is going to be less than or equal to 20 times 1 minus 0.7 to the nth power, all over 1 minus 0.7. Okay, let's simplify this. This will give you 0.3. Okay, so we can get rid of the 20 and the 0.3 by multiplied by the reciprocal. So 0.9 is less than or equal to 1 minus 0.7 to the nth power. Okay, so let's add the 0.7 to the nth. Subtract the 0.9 from each side. And then we have 0.7 to the nth power is less than or equal to 0.1. Let's take the ln of each side. Divide each side by ln of 0.7. Now ln of 0.7 is a negative number, so we're going to flip the inequality symbol. And then when we put that in the calculator, you get 6.46. And then it would be after the 6th dose, during the 7th dose, that the person would have at least 60 micrograms.